Okay, let's look at this question, which says the length of a rectangle was reduced by what? 10%, and the width was increased by 20%. How does this affect the area? Now let's just have a sketch of a rectangle. So they said the area, how does it affect the area? So the focus is on the area of this rectangle. And we know that the area of a rectangle is what? Length times width. All right. But this is the original area of the rectangle, LW, that's length times width. But now they said the length was what? Reduced by 10%. So originally it was 100%, right? When you reduce it by 10%, you have to do 100% minus 10%, which gives you 90%, right? 90% of L. And then what about the width? Increased. So you add 20% to the original 100%, giving you what? 120% of the width. We want to get the area of this now. And let's see how this affects the area of the rectangle. So the area of this is going to be, as usual, length times width. So there's 90%. You can do 90 over 100. That's 90% if you are converting it from a percentage to fraction. Length times 120 over what? 100 width. So let's reduce this now. Now, let's try to keep 100 in the denominator so it will be easy for us to convert it back to a percentage. So 0 cancel 0, 0 cancel 0. I'm not going to touch this one. 9 times 12 is what? 108. Then you have LW. L times W is LW. All divided by what? 100. So it's easy to convert 108 over 100. Of course, that's 108%. So that's 108% LW. So what does this mean? Like I said, originally it's supposed to be 100%, but now you have 108%. So it means that the area has been increased by what? 8%. There you go. I'll see you in the next video.